Hello everyone. Today we are diving into the world of online algorithms. These are algorithms designed to process input sequentially, meaning they make decisions as they receive data, without knowing what's coming next. We will also discuss competitive analysis and online computation. Online algorithms have a couple of key characteristics that set them apart. First, they make irrevocable decisions. Once a decision is made, there's no going back or changing it later. Second, these algorithms operate with no future knowledge. They have absolutely no information about what input requests or data might arrive in the future. To evaluate how well online algorithms perform, we use a framework called competitive analysis. This involves comparing the performance of our online algorithm against the optimal offline algorithm. The optimal offline algorithm knows all the future data in advance and can make the best possible decisions. The competitive ratio is the cost of the online algorithm divided by the cost of the optimal offline solution. There are different ways to define the competitive ratio. First one is absolute competitive ratio, which is the worst-case ratio across all possible input sequences. Other one is asymptotic competitive ratio, which describes the behavior of the ratio as the input size grows towards infinity. Let's look at a classic example, the paging problem. Imagine you have a cache of k pages in memory. When a requested page is not found in the cache, you have to decide which page to evict or remove to make space for the new page. Some common online strategies for this include first in, first out, last in, first out, and least recently used. One popular strategy for the paging problem is the least recently used, or LRU algorithm. Here's a simplified version of how it works in Python code. We define a function LRU_evict that takes the current cache and the new page as input. First, it finds the least recently used page in the cache. Then, it replaces that page with the new page, and finally the function returns the evicted page. Online algorithms are used in many different fields. They play a crucial role in memory management like cache replacement and virtual memory systems. They are also used in financial trading for portfolio optimization and managing risk. Load balancing is another key area, where online algorithms help distribute requests across server clusters. Finally, they are applied in routing problems such as navigation and network packet routing. To summarize, online algorithms make decisions without knowing the future, so they need to be robust and reliable. Competitive analysis is the method to evaluate and compare the performance of these algorithms. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.